Sensitivity analysis can be done with discount rate as well as we have done with benefits and costs. So now we will do this thing here, and for this we are using the same stream that we have used before. It is the Lahore Sialkot motorway project with this set of benefits and costs. This is the discounting factor at 12% discount rate. This would be the net benefits, which is the difference of these two values, and then we have the discounting factor, which is a new one. So this is the new thing that we are trying to do here, the new discounting factor, because this time the change is in the discount rate. So for the calculation of the discount rate, we are choosing this cell in which we are going to add a certain percentage of the original discount rate, which was 12%, and that certain percentage is hidden in or placed or fixed in I1 column. This is that neighboring column cell in which we are noting that unexpected increase in the discount rate. So the original discount rate and the increased level of the discount rate will give us the overall new level of discount rate. So let's do some experiment here. Actually it is 121.449. however, let us start with the beginning. Let's write 0 here. It means that it is the discount rate, the original one, because there is no change in the original discount rate. It remains 12, as you can see, 12% plus no increase in the discount rate because I1 is 0. So let's experiment with before we go there, just see that NPV is 41.234, which is the original NPV. So it is the main case, the baseline case. Now we are going to do some experiment. For example, 10% increase will decrease NPV and make it 35. Now we experiment 20%, it will make it 30 currency units. But how this thing is getting updated, this is an interesting thing. What we do here is we are calculating a new discounting factor, which is shown with the help of this bar, and that new discounting factor is basically 1 over 1 plus the new level of the discount rate, which is here in J1, and then the time, which is D3, which is the value of serial number of time. So the new discount rate that we develop here, which is after the addition of the increase in the discount rate, will be used here. Again, let us see if it is doing the right thing. That is, the time period is correct, and this is a fixed cell over here, J1, and you can see that the calculation is going in the right direction. So as I change this value, that is for example 30, you can see 14.40 will change. Now it is 30% of 12% added into 12, which makes it 15.600, because 30% of 12 would be 15.60. Now this is the new discount rate which is being used here, and this discounted net benefit column is now a new column which is giving us the discounted net benefits after change in I, that is discount rate, and bar shows that it's a new value. And this is the product of the new discounting factor, DF bar, and the net benefits. Here you can verify that it is the product of discounting factor, the new discounting factor, with the original net benefits, because in sensitivity analysis we do not change the more than one variables at a time. So the benefits and the cost, they remain the same, so does the net benefits. And the discounted net benefits, now they are calculated, and we can simply add them. We have taken the sum of these, and it's 26.0402. So now you realize that how these things are getting updated automatically. Let me experiment with something larger than this. For example, 60%. It is still positive, so it's far from being precise. So we jump a little bit. You can do this experimentation, but here I will save some time. And as I have done the experimentation before, a 121.449% increase in the discount rate would make it 26.574%, at which we have calculated this discounting factor, and these net benefits are discounted at the same discount rate, due to which the NPV is equal to 0.0043 with a minus sign, which is definitely not a precise value, but still it is close to 0. So this means that IRR is equal to the new value of the discount rate. In other words, what we are saying is that IRR is that NPV, is that discount rate at which NPV is 0. However, what we have learnt is that as compared to the original discount rate, if we add a certain percentage in the original discount rate, we get IRR, and that certain percentage increase is known as the switching value of the discount rate, which in this case is 121.449, roughly speaking. You can do a little bit of further experimentation and see that which value fits the most. For example, I am trying with some lower value than this, so that it becomes positive. The negative sign, it gets removed, and still it is not there. 2.5 for example, 2.1, now it is with a positive sign. So it seems that this is a more suitable value. We are further increasing it to see that what works the most efficient. Here I think using this value is more suitable, because the NPV is still positive with no negative sign, and is 0 up to 3 decimal places, and this is 26.571, which is the IRR, which is equal to the sum of the original discount rate, which was 12, and the switching value of discount rate increase in the original one, which would make it 26.71%. So in this way we have done the sensitivity analysis of the discount rate, and we also created a link between the switching value of discount rate with IRR, and all of it was done by using Microsoft Excel. This closes the topic of sensitivity analysis on Microsoft Excel. Thank you.